Does the decision boundary look like then?
Circle is very small, the algorithm becomes hyper-local. It's only looking at the single closest point. The decision boundary becomes incredibly complex and jagged. The 1NN boundary, for instance, essentially maps out something called a Vornoi diagram. Basically, every point in the space gets classified according to the label of its single nearest training point. You get these very sharp, angular boundaries between classes.
And what's the big danger of having a boundary that's that complex?
The main danger is high variance. The boundary becomes extremely sensitive to individual training points, and that includes any noisy or maybe even mislabeled data points you might have. If a single outlier happens to be the nearest neighbor to a new test point, bam, the classification is wrong. This high sensitivity means a small dollar leads to a really high potential for overfitting the training data. It learns the noise, not just the signal.
Okay, so if small dollars is noisy and leads to overfitting, why wouldn't we just crank dollar way up, make it a really large number, maybe half the size of the entire training set? Wouldn't that guarantee a nice, smooth, generalized decision boundary?
That's a very logical thought process because increasing dollar definitely smooths out the boundaries and reduces that variance problem we just talked about. However, setting a dollar too large introduces the opposite kind of error bias. If your neighborhood, the group of tall points you're considering, becomes too expansive, it might start including points that actually belong to other classes, even if your test point is deep inside its own cluster. The classifier then ends up averaging across these different classes, which leads to inaccurate predictions. It starts to underfit the underlying pattern because it's smoothing things out too much.
Yeah.
So yeah, selecting dollars, it's that classic bias variance trade-off in action. Finding the sweet spot is key.
Right.